Welcome to Industrial IoT Live Lab here on Industry4.tv. So this is a session that we conduct weekly, a live demonstration where we get to explore some tools and techniques to help you build a connected factory. So if you're new to this channel, make sure you subscribe. If you're watching us from YouTube, make sure you subscribe and click on the notification bell so that you can get all these shows notified to you whenever we go live. So today I've got a very special guest, Jeremy, who's the CTO of United Manufacturing Hub. So Jeremy, why don't you introduce yourself and your company to the audience?
Yeah, hi, I'm Jeremy, and I love demos. I love product demonstrations because I was a system integrator before, and I've seen a lot of presentations, PowerPoint slides, and everything was promised that you could get. But once you actually were using the product, you were identified, oh, this is not what I expected there. So I really love product demonstrations. And this is what we're going to do today. So thank you, Kutsai, for the invite. And what the goal of this demonstration should be is that we want to show you what we are as a company, what we do, what our product is, the United Manufacturing Hub integrated platform, and then go into the details, show the management console, and show how you can set up one device, how you can work with Node-RED and Grafana, and with the entire infrastructure. And our goal is that you can focus on manufacturing, not on tech stack maintenance. This is basically the vision of our company. Yeah, should we get started, or
Yeah,
do
sure.
you? Okay,
Yep.
perfect.
So maybe quickly before we get started, just to mention to our audience here that we are coming from you live. So please, could you just let us know where you are joining us from, and let us know if we're audible and visible. Just leave a comment in the comment section. Let us know where you are joining us from, and please, if you could be so kind to let us know if we're audible and visible. And again, during this session, feel free to drop in some comments. If you've got some comments from some questions from Jeremy throughout this session, feel free to drop them on the comment section, and then I will get to those questions and answer them live. So yeah, today Jeremy is going to show us how to manage your company's IoT infrastructure with the United Manufacturing Hub. So over to you, Jeremy.
Yeah. So let's get started. Let me explain the company, the product, and then the most exciting part, I think, the live demonstration, so that you see what we can offer, what we're offering, and that it's not bullshit. So about the company, I don't want to make it too long or show a company presentation. Let's make it very, very concise. We're around 10 people. We have a lot of large enterprises as customers, entirely international. So even though we're based in Germany, we have customers in the US, down to Singapore, basically the entire world. The only continent that's missing is actually Antarctica. So if you're sitting there, feel free to contact us. And so most of our company, what we're building around is open source. So what does open source mean? It means that the main product that we're developing and selling is in its core open source. So you can just download and try it out during this live presentation. There's nothing stopping you. But what open source also means is that we build up a community. So we have a lot of blog articles and about different tools and techniques for scalable data processing, for example, to help you guide in your journey. And also, we have a quite large community on LinkedIn, Discord. So if you want to exchange with other experts and people in the field, feel free to join there as well. So to get to the product, so this was everything about the company, the product. We just have released the new website. And with the new website, we are Let me wait a couple of seconds until it shows up. I hope it shows up now. With the new website, we are showing what our product is, the UMH integrated platform. So if I would bring it down to just a couple of sentences, it's the UMH integrated platform is a cloud-based application designed to manage your entire company's industrial IoT infrastructure. So it gives your engineers all the tools they need to manage their data infrastructure, to manage their devices and container infrastructure, because the data infrastructure needs to be installed somewhere. Install it on devices on the edge, on premise, in the cloud, and it all provides it in a single tool that helps you navigating this, because a lot of you want to use tools like Kubernetes, Kafka, etc., but I'm a little bit worried about, hey, how does it work in my company? So this is the third component, the management console, which helps you in keeping the overview over it, in interacting with the system, building it up, configuring it without getting too much in detail. So let's start with the data infrastructure. This is the part that we've been known for the longest time. It's the part that has also been open source for the longest time. And this is about like, how does the data flow? So we have the automation pyramid with a strict hierarchical data flow. So we have like sensors, PLCs, they all only talk to each other. So only like one layer with another layer. And what most of the companies that we see and most of the enterprises that we see is what they're doing is they're adding the industrial IoT to it, or the unified namespace, or there are a lot of names out of it. So, and basically the goal is always extract data out of all of these layers and put it into more flexible data flow so that you can build applications on top of it that take data from all of these layers and process it and create really nice dashboards and use cases with it. And to do this, what we offer is you have on the left the automation pyramid. And now what we provide is a connectivity layer. We will go into the details like how the components look. It's a connectivity layer to extract the data from all of these systems. In the middle, you have the message brokers, also called unified namespace, leveraging -q. And on top of that, we have two directions where the data flow. And this is also something where we will get in 30 minutes, because this is like where a new article was just released from our side. So there are two paths. One are the application for the frontline workers. So the people who are in the factory that want to have access to the historical records, and they just want to see in real time how the factory is behaving. So you have features like historian and real-time analytics in it. And the second path is the data lake. So for the business analysts. So there are a second group of people that are typically not on the shop floor, business analysts, any other knowledge workers, the people who are creating the reports, and they want to take the data and put it into their warehouses, Amazon Redshift, Synaptics, I think, for Azure. So to send it to the data warehouse. And how we do it exactly is we leverage well-established and open source tools. So we have, for the connectivity layer, we are using by default Node-RED, which provides a lot of OT protocols and IT protocols, and which we will use also in our demo. We see that a lot of customers of us, they tend to play with it and mix it with what they already have. So I think this is an entire different topic, what connectivity tools to use, but we see most enterprises somehow putting Node-RED into the mix between Kepware, Node-RED, and other solutions. So we put it in there as a default connectivity solution. Then we provide additional connectivity options for its very specific use cases. If you want to retrofit with IFM sensors, if you have OPC UA server, I don't want to go too much into the details. You can read it all up. In the middle, we have the message broker, which consists out of MQTT and Kafka, which provides you with a unified namespace and also connectivity to the data lake. And all IoT devices are directly connected to HiveMQ, to the MQTT broker, because it's really good at handling a lot of, I think there was a couple of weeks ago, there was an article published by HiveMQ showing how they're able to handle like 1 million or 10 million connections at the same time. So this is really where MQTT really excels at. But MQTT is not that good with processing a lot of data. It's good at handling the connection and fetching the data, but not at taking data out, processing, sending it back, these multi-step calculations. So for this, we introduced Kafka, which is very good for processing data, but really struggles with keeping unreliable connections. So we have both of it. And then on the part of the application for frontline workers, we provide the data storage. In this case, it's TimescaleDB. We've written a lot of articles about it compared to InfluxDB, so I want to go into the details. And Grafana for data visualization, together with our own API, so that you have features like historian, shop floor KPIs, or alerting immediately out of the box. So now you have this data infrastructure, and something that gets forgotten often, but is really important when maintaining and integrating the system, is where it should run on. And this is the second part of the UMH integrated platform, the device or container infrastructure. So you have this data infrastructure, and now it needs to be installed on the edge, on-premise, and in the cloud. And you typically need all of these three components. You need the edge because you have very often, especially in large enterprises, demilitarized zones. So you need to put in kind of a device there that sends the data out. You have on-premise. You need something on-premise, especially for critical services that require low latency. And you typically also want to leverage the cloud for all the cloud functionalities. So what we do is, and we've seen a lot of large enterprises doing it as well, they typically put one single layer, one single maintenance layer, configuration layer on top of edge, on-premise, and cloud. And this is very often Kubernetes. So Kubernetes is a tool which helps you with high availability, with scalability. It can be a little bit complex, but this is like what cloud people are used to. And I would say it's even more complex if you would use for edge and on-premise and cloud a different system. So we're using Kubernetes as one central system. And then we need to, and the infrastructure is deployed as a Helm chart on top of Kubernetes. And now the question is, how do we get to Kubernetes? And for this, we have automated provisioning. So it doesn't matter whether you have an edge device, an on-premise server, or virtual machine, or the cloud. In the cloud, you use something like a managed Kubernetes. But for on-premise and edge, we provision it entirely from bare metal. You just basically put a USB stick in, you press start, and you automatically install an operating system, in this case, Flatcar. If you want to do, there are articles from us that explain why we chose this. Then it installs a minimalized version of Kubernetes, K3S, which is really easy to maintain, but still provides this Kubernetes abstraction layer. And then we install the Helm chart on top. And the entire provisioning is entirely done by the management console as a third component, with end-to-end provisioning and management. And this is what I want to show you now. I'm just taking a look. Perfect. There are no questions. Nice.
Yeah. So
let's go to
yeah. If you've got any questions for Jeremy, feel free to drop those on the chat.
Also, hi, Daniel.
Yeah. Hi, Daniel. Hi, Einstein and Cohen.
So, management console. So, we've seen a lot of people and enterprises are thinking, oh, this is awesome. This Kafka Kubernetes, and you need to deploy it, but it's so complicated, so many moving parts. So what we do is we're developing the management console. It's a supervisor or watchdog that puts all of the functionalities in a user-friendly interface so that you can configure it, manage it, and monitor the entire infrastructure. Not only the data layer or not only like the container layer, but the entire infrastructure. Because if your MES guy calls you and says there's no data coming in, you don't care if it's because of device or etc. You need to solve the problem within minutes. And this is what the management console is designed for. So first, and this is what we will look in a couple of minutes, a tool to configure and monitor all of your components. So everything from hardware to software to APIs to data streams. And if something goes wrong, get immediate alerts. And if something goes wrong, automated backups with root cause analysis, and you can control all changes with authentication authorization across the entire stack so that not everyone in your company can do everything, including audit trails and versioning. And you also, so this is probably more for the IT kind of person who needs to maintain it. There's also the other part, and this is about data streams. So if you have this architecture, and especially when thinking about large enterprises, it can get very, very complicated. So what you want to know is where, if you go to your unified namespace or go into the database, where did this data come from and where does it go? So we provide tracing functionality that you can see with one click, hey, this data point, it came from this PLC, and it's really easy to do with Apache Kafka headers or MQTT5 headers. And now the people can work with the data and just focus on the data layer, transform it with we're using Bentos or with Node-RED, and this way we're catering to the two needs of this infrastructure. First, the people who need to provision, configure, and install it and maintain, and then the people on the shop floor who have all the expertise and want to understand the data streams, the data that is coming out of the system. With this, I think enough talk. Let's get started by looking into the management console.
Yeah, so before we jump into the management console, there's a question. I'm not sure if you are going to get to that, but feel free to address it now if you feel you.
Oh yeah, hi Amin, nice. Oh, I mean, first we will see one of your simulators actually in the presentation. We will connect to it and process it. So I think it could be nice for you to see that your open source project is actually used. It's installed by default. The first question is industrial drivers. So we have, by default, we're using Node-RED. We have the additional layers for components for barcode readers or IFM sensors or OPC-UA servers. But we don't provide additional drivers because there is so much on the market that we don't think it would be a waste of time for us to just redevelop everything. I know that there's Kepware. I know that Litmus has a big driver library, so there's no need to redevelop everything. Yeah, and the second question is how Benthos is used. We use it as a tool. So actually our OPC-UA connectivity part is actually a plugin for Benthos, so that you can use Benthos and just write like OPC-UA, type in the server name, and that's it. And that you have like a very easy way to put additional data connectivity or data transformation part into your Kubernetes infrastructure. Really easy to monitor and maintain. It will not be part of this demo because I think it could be a little bit too complicated. Here we will just show Node-RED, but yeah, maybe we can talk about it afterwards. So let's open up the management console. There we are. So So I already locked myself in. The security technology behind it is a patent pending. So I don't want to go too much into the details there. But basically, what the management console allows you is to access all the devices and to set up them via the cloud without, and we can prove it mathematically, without the need to give your data to the cloud provider. Interesting technology. So you see one device here. It's just like from a previous demonstration. So this is the management console. And let's take a look first at the device and provisioning part and install something here locally on this laptop. And then what we can do is we will go to the data infrastructure part and work with it. So we can add a new device. We can deploy it either on the edge, cloud, or virtual machines. But if you haven't worked with it so far, and I only have like this laptop right now, so just install locally on this this computer here. There are two ways to do it. We choose the most easiest one. It's using K3D, which, by the way, could even come also from, I'm not sure about this one. So we just installed on this computer. There's just like Docker desktop running here. It asks you what type of cores and memory you need. There's already an instance running from a previous demo, so I'm just going to overwrite it, and it will start the installation. So what happens now is that it will, there's Docker desktop running on my laptop, and will automatically spawn up a Kubernetes cluster in there using K3D. And it will automatically install the United Manufacturing Hub, the Helm chart, the data infrastructure on it. It will, once the initial installation is through, it will still take around 10 minutes to be actually finished. So here it's installing the Helm chart. Just give it a couple of seconds. Now it's finished. Now it shows up here, and it's still not connected. So this is going to take, I would say, 10 minutes or something until everything's installed. Beware what's happening. It will install Node-RED, it will install -QSM QT broker, it will install Kafka, it will install Timescale DBS database, it will do all the connections through it up to Grafana. So the internet connection is good, so I don't think it's going to take the whole 10 minutes. Maybe let's take a look whether there were any other questions.
Yeah, so while we wait for the installation to complete, feel free to drop your questions or comments in the chat here, and then we could have Jeremy answer those ones.
Yeah, we see the first connectivity thing was already started. So now we see some of the pods are green yellowish. This means they're currently setting it up. We could even deep dive into it using Lens. Let me open it. Let's tool to manage Kubernetes cluster, so we could take a look exactly at what's going on there in the background. And then I think I could use the time to tease you a little bit about the new article that I just published, but it's not published on LinkedIn yet. So you would be the first person to actually hear about it if you're not joined our newsletter or if you're not in our Discord channel. So I'm now connected to the local K3D instance. I can go to pods and select the United Manufacturer namespace, and you will see everything in the background is starting. A lot of it is still orange. It always looks kind of dangerous. It's just like the way Kubernetes is. We will see here also, yeah, this simulator, it's already started up, which just sends some simulated data to MQTT. So let me, in the meantime, show or tease a little bit the new blog article, because I think this is interesting for most of the people here. So it's about integrating the unified namespace into your enterprise architecture. So you typically all have unified namespace, but you might be wondering, and I talked a little bit before already, how does it work with this data warehouse, a data lake? And I've seen enterprises that and people there that want to use something like a unified namespace, but they're not able to explain it. Their managers to how does it fit together with a Power BI, or why do you need a historian or something like it on premise? And what it does is it first explains some theoretical concept, just some very well-known IT best practices, and then it applies them on the topic of unified namespace. So the first thing that's been done is the difference between OLTP and OLAP databases, online transaction processing and online analytical processing. So you have databases like SQL databases, which are there for the frontline people and which are very good for handling a lot of updates and a lot of smaller queries, but they're really not good at letting like batch jobs over a couple of hours. And then you have the OLAP systems, the data warehouses, which are really not good at real-time data, but they're very good at long analytical queries. And how you typically connect them is through ETL process, extract, transform, load, where you take the data of the database, you push it into a data warehouse. And in modern times, this is typically done with something like change data capture, which is a method to subscribe to all the changes of the database and push it into, in most cases, it will be Kafka, and push it into Kafka. And from there on, you put it in the data warehouse so that you get it in more real time, not in batch jobs anymore, but in real time. And this starts to look like a unified namespace. Kafka, we already know, kind of message broker thing. It's not the same because Kafka can be used for back pressure handling and stuff like this. But I just explained it like why we think MQTT Kafka is the best way to go. And still installing. The second theory is the Lambda and Kappa architecture, which are architectures to process really large amounts of data. So the traditional one is the Lambda architecture, which has like a batch layer, a speed layer, a server layer. So data is coming in via Kafka. You have this real-time processing. Then you have some kind of a in-memory processing. So in the batch layer, data is stored, and then every night or in batch jobs, there are continuous batch views coming out of it, so that you can access data that is real time, but also data that would typically require very long queries to run. Example is predictive maintenance. Speed layer is just vibration data coming in, applying the ML model, and batch layer would be taking still all the data, but then training the model on it every week or so to provide a new model, which can then be deployed in the speed layer. And then and started to look good. What you then can do is you can start to put all together into a standard architecture. And I think at this point, it's a very good thing to stop and switch over back to the management console. If you are interested in learning more about it, check out our website and the article. It was only published in the newsletter on our website yet. Next week, it will come on LinkedIn as well. So this is like kind of a quick teaser preview that you get here. There's yeah.
Yeah, I think Daniel has got a question. So
yeah,
go on.
You go ahead.
Yeah, so I was saying Daniel is asking why Kafka and not RabbitMQ or something else.
Yeah. So tools like RabbitMQ are message brokers, and Kafka is focused on event streaming. It sounds like this is almost the same. It's not if you think about how it works from a technical perspective. So you have Kafka, and how it works is all incoming messages are written to a log, which is like append only. So every new message, it gets like a typical logs that you also know from automation, always at the end. And then consumers can go from it from top to bottom. And message brokers, on the contrary, are more designed, something like MQTT is designed for real-time communication, but it does not provide the capabilities to handle something like back pressure. So what happens if a message broker will not guarantee you that the message was also processed. It will only guarantee you that the message was delivered. Sounds like a small thing, but imagine something. There's a microservice coming up which is processing data, and there are 100 messages coming in. It acknowledged them, it got them, but after it got it, the microservice crashes for whatever reason, program error, whatever. When it restarts, it will not, these messages will be lost. So this is like, it sounds like edge case, but if you start to have a lot of processing layers after each other, it will become, your system will become more affected by these types of edge cases. So this is why you would use something like a Kafka. So it's like two different things.
Nice. And Amen is asking if are you using Kafka as the broker technology behind UNS?
So in the background, there are two brokers actually. So there is MQTT and Kafka, and both of them are syncing the data with each other. So it doesn't matter if you are sending data from an MQTT device, it will ultimately land on Kafka so that you can then reliably process it. And also, if the data is coming from a change data capture, like Debezium, you connect it to your ERP, you put it in Kafka, you can still access it via MQTT, as a very simple example.
Okay, we've got another question from Zulfika. I hope I'm pronouncing your name right. Hi, Jeremy. Glad can join the session. For example, legacy MES might not have Kafka connector. Maybe it can be WCF, REST, or etc. How do we connect to Kafka? Should we create middleware?
Yeah, so with the legacy MES, typically MES is nothing more than a database. And this typically OLTP database, SQL database, and if it's based on something like Microsoft SQL, Postgres, MySQL, you're very lucky because there are tools like Kafka Connect that are able to, or Debezium, that are able to take all these changes that are happening in the database and push it out there. For the more rare databases, and for example, SQL Anywhere, which it's an old database from SAP, it might be a little bit more difficult. From there, it could be, what could happen is that you still need to do something like this yourself. You would work in batch jobs or something, fetch all the new orders that have been created or changed in the past 1 hour and execute it hourly or something. This would be the way to do it, or at least how large enterprises are doing it. Nothing is stopping you from like connecting to the REST API, etc. But this is like typically the approach what the large enterprises are doing.
Okay, so
really
shall
thank
we
you for
go ahead
for all the
yeah?
questions.
Yeah, absolutely. Thank you so much. I hope this answers all your questions. If not, please feel free to post some follow-up questions. So yeah, sure. I think we can go ahead with the demo.
Yeah, so everything is now agreed. So which means everything is installed. So what we can now do is we will first start Node-RED. Or not start, it's already opened. It's running perfectly fine. It's accessible, no warnings. And we can press here now on open Node-RED. Now I need to work a little bit with quickly changing the screens so that you see what just happened. So Node-RED was opened, and what we can now do in the management console, it will present you with a small tutorial that you can follow. Let me open it, which you can follow, which will also, so what I'm going to show you, which will show it to you as well, if you want to do it in your home. So let me open it as a reference. Let me open Node-RED. So there is, as remember, there's Node-RED, and it's the connectivity layer. There's a unified namespace, and in this case, there's already simulated data coming into the MQTT broker. We can see it by in Node-RED, selected MQTT in, adding the new broker. Find it also in the management console. There's a link here. I know it because it's hard to remember. Now it's minus manufacturing of minus hub minus MQTT. Let's subscribe to everything, and we will see I'm adding debug node, and we will see the data that's coming here. So apparently there is IoT sensors with pressure, temperature, and humidity coming in. And now what we will do, I'm just following the tutorial here, is we will subscribe to only the temperature. We will convert it because it's coming in as, we will add JSON node, we will add a function node. You can all read it up if you want later. Also don't want to spend too much on the details here. Copying it in. This one. This is like one of the disadvantages of Node-RED. It's changing quite quickly. So there's an article coming up on how you can handle it. What we just saw is that apparently the parse float function was changed, how it's to be called. So you need to remove it, but it will also tell you that. So what we now do is we took in the data from the sensor, from temperature. We process it according to the UMH data model. You can just read it up. But basically what we're doing is we're adding a timestamp and we're adding it into a different topic. And now you can MQTT out. Just send it out back to the broker. And I'll do it. What I'll do additionally is so that we see that it's working. Connect this to the debug node. So if I redeploy, we will see. Or did I do any? No, I did everything correct. Copied everything. That the data coming in here from the simulated data, which could be any MQTT device, PLC, whatever, it's processed according to the UMH data model, and it now lands up in this topic, which we can see here on the right. And what we now can do is we can open up Grafana, and we can take a look at the data. This is everything that you need to do. The Unite Manufacturing Hub takes care of everything in between. So let's open up the management console. And open Grafana. And here we have the credentials. I can show them because it's only locally on my PC. There's a button to open Grafana. It prompts you with username and password. Now the username is admin. The password I need to copy from the management console. And now what we can do is what we just added here at the topic. If you remember it in Node-RED, you could see it. Here switching is a little bit quicker. We added into a topic called Aachen testing process value. So we see it again here, Aachen testing. Now we can, if you send it in what we now just did is we use the historical functionality. We can just take a tag and push it and get stored. You could also transform it into something like add order or something so that you can have here pre-calculated KPIs like OEE and stuff. In this case, let's just add open the temperature. And we see it now. So this is basically it. And now we can build cool looking dashboards with it. I'm not going to do it. I think you have also way more creativity than me. But what you can now do is you can combine this. You can combine this with the advanced data capabilities like OE and create really nice looking dashboards, while also having the entire system that's underneath it entirely based on IT best practices. Kubernetes, Kafka. You can monitor everything with the management console, so it's entirely scalable. And I think from my side, I'm coming to the end of the demonstration. So if you have any questions, feel free to put them into the chat or something that you would still love to see. Because what we saw is I presented you a little bit the company, open source. We looked at the three components: data infrastructure, device container infrastructure, and the management console. We looked at the live demo to show you that it actually works, that it's not bullshit. Coming back to the original thing, why I love demos. I love it because you can see what's actually there and working. So you saw it is working. This entire infrastructure, super complicated, can now be managed in a simple screen. And if you want to talk more about it, either put down questions here, join our community or Discord or LinkedIn. It's just a click away, or even maybe try it out on your computer. It's really easy to set up, as you just saw. So giving back to Kutsai.
Thank you so much, Jeremy, for an incredible demo session. I personally love how the interface really works and guides you along the process as you kind of like go through all the different components. So that's also something that is very interesting for me. So again, I mean, if you've got questions, please feel free to drop them in the comment section here. And as Jeremy mentioned, we'll provide the links to join all the different communities where you can find out more about United Manufacturing Hub. And then maybe if you have got follow-up questions after this session, feel free to send those directly to Jeremy. So we're just going to give it a few minutes here and see if we do get any questions.
Yeah, Kutsai, do you have any questions or any comments on the article or?
Yeah, I mean, for me, the article really it's an interesting one. I guess what I really kind of like wanted to find out more was about like the integration from Kafka to other enterprise applications. You mentioned something about that being real time. How real time is it? Like what are we talking about here when we say Kafka is real time? How real time is it?
Yeah, so we've made it depends on how you optimize it. So, for example, for storing in the database, we've did a small trade-off there. We said, okay, we're going to gather data for I think 1 or 5 seconds and put it as a batch into the database, because to decrease a little bit the database load. Because if you're getting like 100,000 texts per second, what Kafka is absolutely fine to handle, you need to think a little bit about performance, and this is a way to do it. Otherwise, I think we did end-to-end tests, and we're talking here, if you bring down everything, we're talking like sub 1 second. Sub 1 second, we did it like once with, it was image classification. So there was an image taken with a thermal camera. The image was taken, it was sent to a machine learning algorithm, which classified it. Then this classification was merged with other machine learning models from vibration and everything else. This final classification then was stored in the database. And if we remove this batching functionality, we were down to like 300 milliseconds or something. So it is still quite fast. But Kafka doesn't guarantee you it. So if it doesn't guarantee you that the message will arrive in 300 milliseconds, this is something where a message broker could be more suited. But Kafka guarantees you that each of the messages will actually be processed.
Perfect. So yeah, I think we've got another question from Amin. Amin is asking, what data structure used for the unified namespace?
Yeah, this is a very interesting one, and this will be so I already teased you with the current article. Interesting story how this article came to place, like how to integrate unified namespace into our enterprise architecture. I was writing a guide on data modeling, and I think I wrote to multiple communities asking for feedback and experience. And during writing this data modeling article, I found out, okay, before you can start with data modeling, you first need to describe what's behind it, what's behind what data modeling on what database. So this is how the current article came place, so that we can show you, and this is still work in progress. Oh, I see there are a lot of very good questions. Let me first answer the one of Amin, and then the next one. So the current model that we have in the Unite Manufacturing Hub is very practical driven. It works very good, but might not be the absolute best perfect scenario. So we talk with a lot of large enterprises, and most of them, they tend to go for very similar topic architecture. So there's first the point of this is also where Spark B comes in, where my personal opinion is that in the current version it's not usable because it focuses a lot of single devices and not on how manufacturing companies think about it. But I talked on a conference. I remember sitting together with Kutzai and Jens and from -Q, and he said that they're currently there's some movements in Spark B to ensure that in the future you can also adjust a little bit the topic structure. So what I've seen a lot of large enterprises go for is something like an architect or topic structure like this. You have some kind of unique identifier. In our case, so this is like how it will look in the future in the Unite Manufacturing Hub. So we have something like a unique identifier. So if your company is called UMH, you can just use it, or you can use something else. You typically have a version identifier in it so that you can in the future change the model while also keeping old microservice working. And then you typically have the ISA 95 model, because this is like how most enterprises are just on manufacturing sites are built around. Enterprise /site /area /production line /work cell. It might be a little bit different in process industry. There it's not called production line or something else, but same principle. And then what we do is after we have the ISA 95 model, we put in something like, we call it origin ID. This could, it's Spark B, it's called like device ID to say, okay, where is the data coming from? So what device it is, so that you can theoretically, maybe to explain why we have this structure, you could now subscribe to all the data for a single device. It doesn't matter to which site area production line belongs to. But you can also fetch now all machines from a single production line. So with this, you can really filter it down. And with the following two, you can even filter it down more. At the end, you have the tech. So you don't, it's Spark B, for example, everything is currently written into like one single message. But it would be more better to have it in single messages so that you can later, if you send a lot of data through it, for example, 20,000 tags, that you don't need to parse through all 20,000 tags when working with it, but that you can just say, I just want to be updated about that specific single one. And then we're introducing something like underscore use case, which is then, which helps you in kind of structuring your tag on tag groups. You can basically append any more tags afterwards so that you can kind of do like grouping as well. And use case, what you can do is you can differentiate between structured tags where you define, for example, in your company, hey, every line if you have quality inspection, it needs to follow this specific tag structure. So coming also slowly to the next question with schema registry so that you can incorporate it there. And then we have, for example, we call it local underscore local, where you can just push in everything, will not be stored automatically, but you're able to already send it to the unified namespace so that you kind of differentiate between structured and unstructured, but unstructured is still better than no data. And then from the payload structure, I don't want to go too much into detail. Basically, every message has a timestamp, especially if it's about historians or tags, and then the value itself. There's some grouping functions, tag grouping, so that you can view it in folders. I think not too much in detail for now. And then for the analytics part, we adjusted what we have currently just to be a little bit more ISO 95 conform. So instead of order, add order, it's now called job/add. This is where we go in the future. And to come now to the part of schema registry. This is like the part at the very end here of the article. Is what you want to do is I just talked about it with this unstructured and structured data. You want to prevent that chaotic data or data not adhering to a data model shows up in fields where other services rely on good processed data. So what you typically do is you enforce a standard. So basically say, hey, only if the message really is first JSON conform, also conforming to this data model, depending on the topic, so that you cannot send an add order message to a process value. You can enforce it. And in Kafka, there are a lot of tools out there. There are really way too many tools out there. And for MQTT, I haven't seen much so far, to be honest. In this example, what I wrote when thinking about the first article was, I know that HiveMQ, that you guys are, that you're calling it data governance hub. Maybe you can explain more if you know it. This is a good way to have this Kafka functionality of schema enforcement to also put it in MQTT. But maybe, Kutze, you can talk more about it.
Oh yeah, sure. I mean, just to kind of like talk briefly about it, this is a data governance hub, right? That allows you to kind of like create some data governance policies, and then put them on your broker, and then this is where all of the messages are going to be sort of like checked against that schema, so that you don't have bad data ending up down the pipeline further, where you need, as Jeremy mentioned, where there's some services that might really need clean data. So yeah, that's really in short about data governance, but we'll also be able to provide some links to find out more information about that. Okay, so thank you, Amin, for the great questions. Thank you. Okay, so seems like we've got no other questions here. If we've got no questions, Jeremy, do you have anything to add? Or otherwise, I think
only that if you want to talk with me, feel free to reach out. Feel free to subscribe to our UMH newsletter or LinkedIn. If you're watching this on LinkedIn, it's very easy. Just press the button or try out the Unite Manufacturing Hub itself. And our company vision is that you can focus on manufacturing and that you don't need to focus on tech stack maintenance.
Awesome. So thank you so much, Jeremy, for the great demo, and thank you so much for our audience for paying your attention, and also for the great questions. So thank you so much. With that, I would like to say goodbye and see you in the next session. Again, we do this every week live, so make sure you subscribe to the channel and click on the notification bell to make sure that you get all these notifications whenever we do go live. So thank you again, and see you next time. Bye.
See you. Bye.